The entire world is currently focused on Elon Musk's space company, Spacex. The enterprise has made a significant progress and achievement in space. They are working around the clock on a reusable launch system capable of returning astronauts to the moon and allowing humans to become multiplanetary. He aims to make a future where starship travel can be used as a point-to-point mode of transportation on Earth. Elon Musk recently revealed changes to the design of Starship, and these changes are great improvements for the process of preparing for an orbital flight with Ship 20 and Booster 4. Let's take a look. SpaceX's Starship program, which boasts the world's tallest and most powerful rocket, will eventually put people and cargo on Mars. The latest prototype, SN20, is waiting for the chance to go into orbit. Several other prototypes have made flights, ground tests, and sometimes even testing mistakes in the effort to improve future flights. On the 8th of December 2018, 9 months after starting construction of some parts of the first test article carbon composite Starship low-altitude test vehicle, Musk announced a counterintuitive new design approach would be taken by the company. The primary construction material for the rocket structure and propellant tanks would be fairly heavy but extremely strong metal, subsequently revealed to be stainless steel. Musk revealed on the 23rd of December 2018 that the initial test article, the Starship Hopper or Star Hopper, had been under construction there for several weeks, out in the open on SpaceX property. The Star Hopper was being built from 300 series stainless steel. According to Musk, the reason for using this material is that stainless steel is cheap, it's fast, but not obviously the lightest. However, reports prove that the material was the lightest. If you take a look at the properties of high-quality stainless steel, the thing that isn't obvious is that at cryogenic temperatures, the strength is boosted by 50%. The high melting point of 300 series still would mean the leeward side of Starship would need no insulation during re-entry, while the much hotter windward side would be cooled by allowing fuel or water to bleed through micropores in a double-wall stainless steel skin, removing heat by evaporation. The Star Hopper had a single engine and was used for a test flight to develop the landing and low-altitude control algorithms. From mid-January to early March 2019, a major focus of the manufacturer of the test article was to complete the pressure vessel construction for the liquid methane and liquid oxygen tanks, including plumbing up the system and moving the lower tank section of the vehicle 3.2 kilometers or 2 miles to the launch pad on the 8th of March 2019. Integrated system testing for the Star Hopper with the newly built ground support equipment, or GSE, at the SpaceX South Texas facilities began in March 2019. These tests involved fueling Star Hopper with LOX and liquid methane and testing the pressurization systems observed via icing of propellant lines leading to the vehicle and the venting of cryogenic boil-off at the launch test site. During over a week, Star Hopper underwent almost daily tanking tests, wet dress rehearsals, and a few pre-burner tests. In early 2019, a storm impacted the Texas site, blowing over the top nose cone of Star Hopper and damaging it. It was thought that a rebuild of the nose cone was required, but in the end, SpaceX decided to forego the use of a nose cone altogether and use the Star Hopper vehicle without a nose cone. Following initial integrated system testing of the Star Hopper test vehicle with Raptor engine serial number 2, Raptor SN2, in early April 2019, the engine was removed for post-test analysis, and several additions were made to the Star Hopper. Attitude control system thrusters were added to the vehicle, along with shock absorbers for the non-retractable landing legs and quick disconnect connections for umbilicals. Raptor SN4 was installed in early June for fit checks, but the first test flight that is not tethered was expected to fly with Raptor SN5, until it suffered damage during testing at SpaceX Rocket Development and Test Facility in McGregor, Texas. Subsequently, Raptor SN6 was the engine used by Star Hopper for its untethered flights. On the 3rd of April 2019, SpaceX conducted a successful static fire test in Texas of its Star Hopper vehicle, which ignited the engine while the vehicle remained tethered to the ground. The firing was a few seconds in duration and was classed as successful by SpaceX. This was the first firing of Star Hopper, the first firing of a rocket engine into Texas launch site, and the first tethered flight, according to Musk in the Starship program. The vehicle might have lifted off the ground, but this would only have been to the height of few inches, and it is impossible to see the liftoff in public video recordings of the test. A second tethered test followed by just 2 days later on the 5th of April 2019. This time, the vehicle rose off the ground to hit the tethering limit of about 1 meter altitude. While the transport system under development in 2016-2017 relied on a combination of several elements to make long duration beyond Earth orbit BEO spaceflights possible by reducing the cost per ton delivered to Mars, the reusability aspect of the launch and spacecraft vehicles alone was expected by SpaceX to reduce that cost by approximately 2.5 orders of magnitude over what NASA had previously achieved on smaller missions. Musk stated that this is over half of the total 4.5 orders of magnitude reduction that he believes is needed to enable a sustainable settlement off Earth to emerge. The two parts of the redesigned BFR were named Starship for the upper stage and Super Heavy for the booster stage, which Musk pointed out was needed to escape Earth's deep gravity well and was not needed for other planets or moons. SpaceX began to refer to the entire two-stage to orbit, fully reusable, Super Heavy lift launch vehicle as to the SpaceX Starship system in 2019, although they continue to use Starship to refer to only the spacecraft. While SpaceX's fleet of Falcon 9 and Falcon Heavy rockets are partially reusable, Musk's goal is to make Starship fully reusable, a rocket that is more akin to a commercial airplane. Both stages were to be designed by SpaceX to be fully reusable and were to land vertically, using a set of technologies previously developed by SpaceX and tested in 2013 to 2016 on a variety of Falcon 9 test vehicles as well as actual Falcon 9 launch vehicles. One major key to making Starship fully reusable is by improving its durability to survive the intense process of re-entering the Earth's atmosphere. Small hexagonal heat shield tiles are SpaceX's answer to that problem. With the previously shiny Starship rocket now covered in thousands of tiles, this is the first prototype of the Starship with a full year shield. The ship is covered almost entirely with a heat shield. The shield goes around the nose, similar to what was present on the spaceship. For the first time, we can see specialized the round tiles, following the shape of a round flap and nose cone. On August 6th, Musk noted that work on the tiles was about 98% done for Starship 20, as the remaining tiles are uniquely shaped and require machining. The next Starship design change is the refueling process. This is a major design change because SpaceX's Starship will not be able to make it to the Moon, never mind Mars, all by itself. To get it into orbit and then continue its journey, each Mars or Moon-bound Starship would have to meet up in orbit with its brethren and other to fuel up for the journey beyond Earth. Understanding the importance of that, in 2020, NASA awarded SpaceX a $53 million contract to perform a propellant transfer demonstration. Combining Starship's rapid reusability with orbital refueling is critical to economically transporting large numbers of crew and cargo to the Moon and Mars. With a reusable rocket, it takes almost all the fuel in the booster and the ship just to put something into orbit. Therefore, if it wants to go for longer trips, it would definitely have to refuel. In May 2019, the final Starship design changed back to 6 Raptor engines, with 3 optimized for sea level and 3 optimized for vacuum. It was also clarified that the initial prototype Super Heavy will be full-size, but was subsequently clarified that it would make initial test flights with less than the full complement of engines, perhaps approximately 20. As the Raptor engine design was iterated and higher thrust versions tested well on the test stand, the number of engines in the Super Heavy booster stage changed. Super Heavy was initially announced to have as many as 37 Raptor engines on the first stage, and a design with 31 engines was the public plan as late as May of 2020. However, in August 2020, Musk stated that the design had changed. It might be 28 engines, as a result of engine design changes, including increased chamber pressure and a higher thrust-to-weight ratio. In August 2020, Elon Musk expected a Super Heavy prototype for September or October. Musk clarified that SpaceX intends to fly hundreds of cargo flights with Starship before carrying human passengers. In less than 2 years, there have been a lot of design changes for both the ship and the booster. SpaceX also clarified that they continue to expect the point-to-point transportation between two locations on Earth use case to be operational and flying large numbers of people within 5 years. The early atmospheric descent tests in 2020 through May 2021 provided SpaceX sufficient test data on the aerodynamics that by July 2021, Starship's second stage body flaps were redesigned to be both narrower and lighter.